Hello guys, welcome back to Maths on African Motives, still on Mathematics Grade 12. In this platform, we shall be focusing on derivatives, that is working with the cubic function, an application of derivatives, and also some parts of factorization of cubic functions or cubic expressions that you might have. So we are given question number 8, which is one of the question papers, Eastern Cape, September 2020, that we are going to focus with. On question number 8, we have the diagram. In the diagram below, we are given that the graph of f of x is given as 2x cubed plus x squared minus 12x plus 9 is drawn. A and B are the turning points. All right, so you're given the point A, the point B as the turning points, and C is the y-intercept, D, E, and F are the x-intercepts. All right, as you can see on the diagram. All right, so the first part, which is on 8.1, was to write down the coordinates of C, the coordinate of C. All right, so C is the y-intercept here, as you can see, of F. So it simply means y is equal to 0. So since we are going to use this f of x, I'm going to just rewrite it down again. All right, so remember, our f of x is being given as 2x cubed plus x squared minus 12x plus 9. Okay, this is our f of x from what we have here. And for the y-intercept, we know that x is equal to 0. So if x is equal to 0, there's nothing here. It's a 0, it's a 0 here. It's a 0, it's a 0. So which means we are going to have y being equal to 9. So that means y is equal to 9. So therefore, the point C can be written as x is equal to 0, y is equal to 9. So that's the point C. All right, 8.2, calculate the coordinates of D, E, and F. All right, where do we have D, E, and F? D, E, and F, these are the x-intercepts. We've got D, we've got E, we've got F there. All right, so this part, we are going to apply the factorization. We are actually going to solve because in the x-intercept, we know that y is equal to 0. All right, so this is x.2, and we are referring to the x-intercepts in this case, where y is equal to 0. So if y is equal to 0, that means the whole expression of 2x cubed plus x squared minus 12x plus 9 must be equal to 0. So you're supposed to solve for x. So in order for you to solve for x, this is a cubic expression. So there are so many ways that you can use the log division manner, the synthetic division. So it depends with which one do you want to use. So as for me, for this time, I'm just going to use the synthetic division. But as time goes on, we shall come back again, work with the long division so that you understand all the methods of finding or solving cubic expressions. So this is a cubic equation that we have. So by applying the synthetic division, the first thing is to find the value of x that we are going to substitute in this expression so that we obtain a 0. So the values of x that you're going to use, you focus with the constant, which is 9. So you're focusing with numbers such as plus or minus 1, plus or minus 3, plus or minus 9. These are the factors of 9. So you try the numbers, which one is going to give you a 0? Like let us try 1. When x is 1, that's a 1 here, which is 2 plus 1 minus 12 plus 9. All right, let's see what you're going to obtain. We obtain a 0. So in this case, f of 1 is giving us a 0. That means we are referring to x minus 1 as a factor. Okay, but this is not going to matter because as we need to solve, so already we know that the value of x which gives us a 0 is 1. So that is the one that you're going to use. So using synthetic division, so it's not like this is the only value. You can try other values, like you can try any other value and try and see if it is going to give you a 0. But since 1 is giving us 0, let us work with 1. So the synthetic division, you're going to have your cubic expression. You just have a small table that you're going to use. All right, so on this table, this is what you're going to do. Please follow out this way that I'm going to represent here. All right, so what you have is the cubic expression. We have got 4 terms on the cubic expression. Remember, it's written in the form of ax cubed plus bx squared plus we've got a, b, c, and d. all right, which are taken from the cubic expression here. The values that we have, this is your A, the B, the C, and the D. So you're going to substitute these values, which is 2, 1, negative 12, and a positive 9. All right. So what happens is that the values that you're going to obtain here are the ones that represent the quadratic expression. So this part here is not valid. And for the cubic expression, if you factor out if it is a factor, that expression that you've removed or that you factored out, the coefficient of A for the cubic expression that we see is the same as the coefficient of A of the quadratic expression. So which means our quadratic expression is going to have 2 on A. So 2 is not going to change, it's going to remain as it is. Okay, so this is the stage that you're going to have. You're going to multiply by x. The x that we substituted here, which is 1, which gave us a 0, is the one that you're going to use. So you multiply 1 and 2. So you multiply these two, you write your answer here. So it's 1 times 2, which is going to give us a 2. Whatever that you're going to have, you add. Okay, so this part here, you add. So it's 1 plus 2, which is a 3. All right, we do the same thing just like what we did. We multiply again. This time it's 1 and 3. So it's 1 times 3. Whatever that you get, you write in the next part there. So 1 times 3, that is a 3. Then you add negative 12 plus 3, which is negative 9. You can even use your calculator to confirm negative 12 plus 9 plus 3, not plus 9, plus 3, which is a negative 9. All right, then we do the same thing. We multiply by 1. So it's 1 and negative 9. Whatever that you get, you multiply in the next part there. So 1 times negative 9, that's negative 9. Then you add just like what we did in the previous part. So you add here 9 plus minus 9, that's a 0. All right. So if truly you have used a factor, here you must obtain a 0. So if you are obtaining another number which is not a 0 here, it means this number that you have used is wrong, or your calculations on adding or multiplying here, there is somewhere where you've made a mistake. So take note, you must obtain a 0 here always. Always you must obtain a 0. Okay. What is going to remain from what you have? You're going to remain with the value of A, the value of B, the value of C of the quadratic equation, which is these three values, 2, 3, negative 9. So these are the ones that you're going to have for the quadratic equation. So we shall have 2x squared plus 3x minus 9. Remember, the quadratic equation is given by ax squared plus bx plus c is equal to 0. So this is your A, this is your B, this is your C. You just substitute in A, B, C, then you equate to 0. So from there, you are supposed to solve. Remembering that already we've got the value of x, which is equal to 1 that we got in the first place. So it's a solution already, this one of x is equal to 1. So here, by solving a quadratic equation, we shall have two solutions. This is a quadratic, the highest exponent is 2. So if you solve this equation, you shall obtain 2 solutions plus the third one, so that we've got 3 solutions since the cubic expression. All right. So on solving this equation, it's up to you. You use quadratic formula, you use factorization. I don't know which method are you going to use, but in this case, I'm going to just apply the factorization method. Multiply the first term to the last term, that's 2 times 9, negative 9, which is negative 18x squared. So what you need are the factors of negative 18x. But if you add these factors, they must give you the middle term, which is 3x. Which terms are we referring to? That when we add, we must obtain that. All right, let's try these two numbers here, 6x and negative 3x. If we multiply 6 and 3, that's negative 18. If we add, that's a positive 3. So these are the two factors that you're going to use and replace them into the middle term of 3x. So our equation can now be written as 2x squared plus 6x minus 3x. You are substituting those two terms into the middle term. Then you've got negative 9 is equal to 0. So as long you've got a quadratic, 4 terms in an expression like that, you can divide them into 2 so that you can factor out what is common for the first 2 terms. As you can see, we've got 2 and 6. 2 is common, x squared and x is common. So 2x is the highest common factor that we can factor out. So if we divide 2x squared divided by 2x, 2 and 2 will cancel, x squared and x, we've got x plus 6 and 2, that is 3x, and x will cancel, so you remain with x plus 3. And you are supposed to factor out a common term between negative 3x and negative 9, which is negative 3, and we've got x plus 3. And as we can see that the brackets are the same here, x plus 3, x plus 3. So you have to factor out the common bracket, which is the x plus 3 out. So if we factor out x plus 3, we are going to remain with 2x, and here we're going to remain with negative 3. So it's going to be 2x minus 3 is equal to 0. This stage, you simply equate each to 0 so that you can have the value of x. So it's either that x plus 3 is equal to 0, or either 2x minus 3 must be equal to 0. So that means x is going to be negative 3, or x here is going to be 3 to that side. That will be a positive. Then you divide by 2. So it will be 3 over 2. All right, so these are the values of x that we have: negative 3, 3 over 2, and that one that we had in the first place of 1. So we are going to have our values of x being equal to negative 3, our x being equal to 3 over 2, or our x being equal to 1. But we are supposed to name these at the coordinates. Remember, we said y is equal to 0. So now we are going back to the coordinates and see which one is it according to the graph. As you can see, D is far away here, so it's a negative one. So the one that is a negative is our D. And if we can cross-check the one with a negative here, which one has got a negative? That's 3, the negative 3. So that's our point D. Okay, so which means our point D is going to be negative 3, 0. Remember, y is equal to 0 in the x-axis. Then we've got 3 over 2 and 1. We need to test and see which one is bigger. 3 divided by 2, that's 1,5. So as you can see, here is the same as 1,5, and 1,5 is bigger than 1. So we are going to compare which one is our value between E and F. E is this first one on the positive, because this is where we have got our 0 here. So definitely E is going to be 1, and this F is going to be 3 over 2. So E is the one that has got a 1, and F is the 3 over 2. So those are the values that we are going to have later on our solution. So we said E is the one that is a positive. So E is going to be 1, 0, and F is going to be written as 3 over 2, 0, or you can write it as 1,50. Okay, so these are the coordinates of E, the coordinates of A, the coordinates of D, the coordinate of E, and also F in that manner. So as you can see, guys, it was a pretty question. Yeah, you just have to work on those questions and revise as much as you can. All right, let's see the other part of the equation. We are given that determine the values of x for which f of x, which is f, is concave down. All right, whenever we are dealing with the concavity, whether it's concave down, it's concave up, we are supposed to work with the first derivative. All right, second derivative, sorry for that, that's the second derivative. All right, so if it is concave down, that means the second derivative should be less than 0. All right. So by doing this, we have formulated an inequality that we are supposed to solve. So from our f of x, we originally had our f of x as 2x cubed. Don't forget your f of x, it was given there on top. So I'm just going to rewrite. Okay, this was our f of x. So we need the second derivative. So let's calculate the first derivative first. The first derivative is going to be 3 by 2. That is 6x. We subtract 1, so it'll be 6x squared. We drop here, this is 2 times 1, which is 2x minus 12. So we have our first derivative. Then the second derivative with respect to x is going to be 2 times 6, which is 12x. Then here we are left with 2. So from this concept, we are saying that the second derivative must be less than 0. So that means this 12x plus 2 should be less than 0. So we shall have an inequality 12x plus 2 being less than 0. So you can solve the normal inequality just the same way you do in solving inequalities, guys. So what can we do? We can actually transpose the 2 to the other side of the inequality, and that will be a negative 2. So it's 0 minus 2, which is negative 2. So you can divide by 12 both sides. So that means your x is going to be less than -1/6. If we divide by 2, it's going to be -1/6. So x is less than -1/6. This is an inequality, not an equation. It's not a point, it's an inequality. So x, we are talking about the values of x which are less than -1/6. If it was concave up, then the second derivative with respect to x should be greater than 0. So you just do the same thing, then you work out from this stage. All right, so that is what we had. Let's check the other part, which is 8.4. On 8.4, determine the values of x for which the first derivative is less than or equal to 0. So already we calculated the first derivative. Here we already have the first derivative. So it's just a continuation. We are going to start from this part that we have here. All right, so we can even do it aside. That's 8.4. All right, so 8.4, we shall have something like this. The first derivative with respect to x, we are given that it must be less than or equal to 0. And our first derivative is given as 6x squared plus 2x minus 12, which is less than or equal to 0. All right, so that's the inequality that you're supposed to solve. So as for me, I can see that there is something that is common here, so I can divide by 2 each and every term, at least so that I can reduce this inequality. I can just reduce the values. So I can have 3x squared, here it cancels, that will be a positive x, here it cancels, that's a -6 less than or equal to 0. So as we know, it's a quadratic inequality. What you need is to find the critical values when you are solving the equation of 3x squared plus x minus 6 is equal to 0. Whenever you're finding the critical values, you are now solving an equation. All right, so definitely have to try factorization and see if it's going to work. 3 and 6, that's -18x squared. Do we have factors of -18x squared that when you add them, they must give you a positive x? Factors of -18, we've got -18 and 1. We have got -1 and 18. We have got -6 and 3. We've got 6 and -3. We do not have factors. We have got 9 and -2. We have got -9 and 2. So we do not have a condition that when we add, we are going to obtain a 0. So this factorization part does not work. We do not have factors. So here, there are no factors. So what are we supposed to do if there are no factors? Definitely, we are only left with the quadratic formula. So we shall apply our quadratic formula, which states that x is equivalent to -b plus or minus the square root of b squared minus 4ac, everything over 2a. So that is the only option that we are left with, whereby our a is the coefficient of x squared, which is a 3, b is the coefficient of x, which is 1, and c is the constant, which is -6. So we can substitute the values that we have. So x is equivalent to -b, which is 1, plus or minus the square root of b squared, that is 1 squared, minus 4 times a, which is 3, times c, which is -6. Okay, so everything should be divided over 2a. All right, it must save. All right, over 2 times a, which is 2 times 3. All right, so from there, it's now, guys, you and the calculator to have your critical values here. All right, so let's see what you're going to have. This is going to be -1 plus or minus. It's best for you to just simplify what is inside the square root, just the part inside the square root. 1 squared minus 4 times 3 times -6. That's 73. Definitely we had no factors because we do not have the square root of 73. All right, so x is going to be equal to, now we can separate the plus or minus here. So starting with the plus, that means we shall have fraction, that's -1. All right, -1 plus the square root of 73, everything over 6. All right, so we are going to obtain 1,257 and so forth, which can be 1,26 to 2 decimal places. So it can be 1,26. So we've got 1,26 or another x, which is equivalent to, if we substitute here, this will be a negative, and that will be -1,59. Okay, so we've got -1,59. So these are the critical values, not the solutions to the inequality. We are going back to the inequality that we had before here. So what are we going to do now to find exact values of x? This is a quadratic, and our a is greater than 0, which is a positive, so it's going to be a smiley shape because it's a positive there. So what are you going to do? You can use a number line or you can use the graphical presentation. As for me, I favor out the graphical presentation more. All right, so this is my x-axis, my y-axis at 0 here. Then we've got negative 1,59 at this point. Then this point we can just say negative 1,26. So like we saw, the shape, it's a cup shaped, which is a smiley shape. So we shall have something of this nature here, which is a smiley shape. All right, so this is our f. For which values of f do we see this f being less than or equal to 0? Because when we are referring to 3x squared plus x minus 6 is less than or equal to 0, we are simply referring to f of x less or equal to 0. And our f is less or equal to 0 when it is below the x-axis. That's a negative, less than 0, a negative. So below the x-axis at these points, that is where we are going to have our solution. So as we can see, our solution is bound between negative 1,5 and 1,26. So therefore, our x is going to be greater than or equal to, according to the inequality, there is an equal to, so we shall put the equal to. So it will be greater than or equal to negative 1,59 or less than or equal to 1,26. So these are the possible values of x, and not forgetting that this x is supposed to be an element of all the numbers that we can think of, as long we are referring to a real number there. So that was it. I think, yeah, it was a straining question, because if you're going to try factorization, because most of these questions, we know that they will be using factorization, but this one, factorization was not going to work. So the only part that we're left with was to apply the quadratic formula to have the critical values. Then from the critical values, you then determine the solution. So that's what we had, guys, on the derivatives, application of derivatives, and also the factorization or solving of cubic expressions or cubic equations. I mean, that part is synthetic division and so forth. So guys, please revise as much questions as you can. So that's it, guys. Till we meet again from Mason African Model.